Hello, Algebra 1. Sorry I'm not in class today. My little kitten broke his paw and I'm at the vet. So here are some review over is it a function. Remember, when we're determining whether a relation is a function, we're using the VLT, the vertical line test. We're going to do one of each problem and you're going to spend the rest of the day in class working on some practice problems. So let's start off with, what if I'm given a graph? So if I'm given a graph, I can skip right to using the vertical line test. So I am going to draw a vertical line on my graph, and I'm going to do my vertical line test. Remember, I'm making sure that my vertical line never hits my graph more than one time. If it hits more than one time, then it's not a function. So as I move my vertical line across the graph, it looks like for the first section I'm only hitting once, and for the second section I'm only hitting once as well. But if I put my line right here in the middle, it looks like I'm hitting my function 2 times. So my first response would be, oh my gosh, this hits twice. It does not look like it's going to be a function. But if you remember, we have a closed point, we call this a point, and we have an open point, or in other words, a hole. A hole does not count as a hit. My line goes right through the hole and it misses the graph. So at this spot, my graph really is only getting hit one time with my vertical line. So my vertical line is only ever hitting my graph one time. Since I'm only hitting one time, this is a function. This is a function. And my reasoning is always going to be one or the other. It either passes the VLT or it fails the VLT. In this graph, we pass the VLT. So it's a function. So if you're given a graph, you can skip right to using the vertical line test. Let's look at the second one. So if we look at number 2, we have these 2 ovals with a bunch of numbers and arrows. This is called a mapping. And in a mapping, the left side are all my x values, and the right side is all of my y values. Now, in order to determine if a mapping is a function, we first need to turn it into a table so that we can put it in Desmos. So I'm going to draw a table, and I'm going to take my x and y values and create a bunch of points and put in my table. So my first number is -1, and that's an x value. And you can see I have an arrow that points to -2. So I know that -2 goes with the x value -1. Since there's only one arrow, we're done with -1. On to +1. Now you'll notice +1 has 2 arrows, which means we have to have +1 twice in our table. One arrow goes to -1, and the other arrow goes to 0. So that's really 2 separate points because there's 2 arrows. Okay, I got all my 1s. Next, I have the x value 2, which points to the y value 2. And I have 3, which points to the y value 2. Now that I have my table, I need to always double check. I have 1, 2, 3, 4, 5 arrows, which means I should have 1, 2, 3, 4, 5 points, which I do. So now that I have my table, I'm going to go over to Desmos. I'm going to click the add item, the plus, and add a table. And I'm going to plug in my table. -1, -2, 1, -1, 1, 0, 2, 2, and 3, 2. I'm going to click on my little zoom fit so I can see all of my points. And now I'm going to check, does this pass the vertical line test? Well, it actually fails the vertical line test. Right here, if we imagine a vertical line, I hit both of these points at the same time, which means this is not a function. This is not, let's try that again, not a function. Okay, and our reasoning is because it fails the VLT. it fails the vertical line test. Okay, so if we're given a mapping, we turn it into a table, put it into Desmos, and do our vertical line test. All right, let's do our next one. Number 3. For number 3, we're just given an equation. We're given a function or a relation we don't know yet. So all I'm going to do is go over into Desmos and type it in exactly as I see. Y equals the absolute value of x plus 3 minus 2. Okay, I'm going to zoom out so I can see most of my graph. And if I look at this, if I were to draw tons and tons of vertical lines, okay, tons and tons of vertical lines, my vertical line will never touch this graph more than once. So it passes the vertical line test. So number 3 is a function. And our reasoning is it passes the VLT. And I'm done. Okay, our last problem is a story problem. So when we're given a story problem, we need to make sure we first turn it into a table. Okay? So Domino's charges $8 for a large pizza and $1 for each additional topping. We need to take this information and put it in to Desmos. So our dependent variable, the variable that changes, is how many toppings we have on our pizza. So the number of toppings. The number of toppings. Our y value is going to be the total cost. The cost of the pizza. The cost of the pizza. So let's say I had one topping. If I got a pizza with one topping, it would cost $8 for the pizza plus $1 for the one topping, which would be a total of $9. If I got a two-topping pizza, it would cost $8 for the pizza plus $1 for each topping, so $2, which would give us a total of $10. If I got 4 toppings, it would be 8 plus 1 plus 1 plus 1 plus 1. $1 for each topping, which would be 8, 9, 10, 11, $12. Okay, if I got 10 toppings, it would cost $8 plus $1 per topping, 10, $18. That's a lot of toppings. Once I have my table, I'm going to go to Desmos, click Add Table, and I'm going to type in my table 19, 210, 412, and 1018. I'm going to click my zoom fit, and this should be a 2. I'm going to check, and it looks like I would never hit 2 points at the same time, so this is a function because it passes the VLT. So there's an example of one of each. What you're going to do now is go into your Google Classroom, click on the document, and practice a bunch of these. Okay, practice for the rest of the period.